For this problem, we're trying to decompose the partial fractions into partial fractions. So it's negative 10x cubed plus 50x squared minus 112x plus 160. And so this breaks down into, so we work off the denominator. So we're going to have an x as a denominator and an x squared as a denominator. Clear that up. And then we're going to have an x minus 4 as a denominator, and then an x minus 4 squared. Now these are all linear terms. Even though we square them, it's that same linear term squared. So we're just going to have a constant for each of these, a, b, c, and d. And one approach that I like to go with this is to just clear out the fractions. Clear out the denominators. And the common denominator is x squared times x minus 4 squared. So if I multiply by, I'm going to write here, multiply both sides by x squared times x minus 4 squared. So on the left, we have negative 10x cubed plus 50x squared minus 112x plus 160. And then we have a times, if we multiply that all through, an x will go away, so it'll be x times x minus 4 squared plus b times, if I multiply through by the x squared times x minus 4 squared, I have an x minus 4 squared. And then the c, if I multiply through, I'd have an x squared times x minus 4. Kind of out of space here. Plus d, if I multiply through, it'd have an x squared there, because the x minus 4 squared goes away. So one approach is to, this is an interesting idea. If we said x was 0, so if I say x equals 0, on the left I get, negative 10 times 0 plus 50 times 0 minus 112 times 0 plus 160. Now on the right, it's a times 0 plus b times 0 minus 4 squared plus c times 0 plus d times 0. So that will clean it up, that we can just say, okay, 160 equals b times negative 4 squared, so that's 16b. So b must be 10. Hey, we got one of them. That's pretty cool. Now let's see, what else can we do? We can probably eliminate 3 of them if we said x is 4. So we said x equals 4. Then on the left, this is going to be a little big to deal with. I'm going to just plug it in with my calculator. So it's going to be negative 10 times 4 cubed plus 50 times 4 squared plus, or should I say minus 112 times 4 plus the 160. And oh my gosh, this can't be real. I get negative 512,288. But on the left, if I put a 4 in for all, anything with a 4 with an x minus 4 is going to be 0. So that's a times 0 plus b times 0 plus c times 0 plus d times 4 squared. I'm just double checking my math because my goodness, that is a big number. Positive, negative, positive. Sorry, negative, positive, negative, positive. That's what it is. Okay. Oh, it's not that number. I have a plus. I have a times where it should have a plus. Oh, that's going to save us again. Okay, much better number now. Whew. So those of you playing along at home probably putting your calculator screaming at me, no, it's not that bad. So negative 128 equals 16 times d. So d equals what? Negative 8. Okay, we got 2 of them. That's pretty cool. Now let's see. We need to get A and C. Thinking of the best way to go about that. There's no really quick ways to do it. I mean, putting in whatever makes that factor 0, we kind of play that out with those two, since they're two factors of multiplicity 2. Okay, so here's another strategy. So we have negative 10x cubed plus 50x squared minus 112x plus 160. So that hasn't changed. What we know now, though, is that we don't know a, so we can call a, and this is what I'm going to do. I'm going to expand this. So that's a times x cubed minus 8x plus 8x squared plus 16x. Plus, then we have b times x squared. We know what b is, though, don't we? 10. 10 times x squared minus 8x plus 16. And then we have plus c times x cubed minus 4x to the 4x squared plus d times, well, you know what d is. D is negative 8. So let's say minus 8x squared. Okay, so with that in mind, I'll take it one step further so you can hopefully see this. We have negative 10x cubed plus 50x squared minus 112x plus 160 equals ax cubed minus 8ax squared plus 16ax plus 10x squared minus 80x plus 160. I just drew the 10. Plus cx cubed minus 4cx squared minus 8x squared. So what I'm going to do now is look and see if there's something that's unique for a. So I have an ax cubed, but I also have a cx cubed, so that's not going to do anything for me. I have an 8ax squared, but I have a minus 4cx squared, so that's not going to do anything for me. But I do have a 16ax, so the coefficient for x, I can look at that. On the left, coefficient of x. On the left, it's negative 112. On the right, and we have a 16a, and I have a minus 80. So I can take that minus 80 and add it to both sides. And I get 192 equals 16a. And I can divide by 16. And a equals what? Okay. And the last thing I could do that would probably make this the easiest is I know that on the left, if I look at the coefficient for x cubed, it's negative 10 on the left. On the right, it's a, which we know is 12, plus c, and that's it. So if I subtract the 12, I get negative 22 equals c. So if I remember the order of things, this was going to be our a, which is 12 over x, plus b, which was negative, was positive 10. 10 over x squared. And then we had our c, so minus 22 over x minus 4. And then d is negative 8, so minus 8 over x minus 4 squared. And that's how you do a decomposition of partial fractions. Okay, hope that helps.